Good day, folks. Some major modifications to my quantum energy generator here. I figured that it was just practical. It seemed to respond very well to high voltage and zero current, so I decided it only made sense to modify the system. So instead I added a primary high voltage cap dump module. It's essentially the high voltage module that charges its own cap, and I'm sending it to the trigger, controlling it with the controller. So instead we have a very high voltage, low current dump going in here. And what that does is it triggers a reactive stage, and I will show you what happens. And remember, folks, this is a different kind of energy. It's a cold energy. It's negative energy. It appears in our capacitors as regular DC. It looks like regular DC, but it does not behave like regular DC. Very important. The only way we could use this power traditionally is to transduce it or convert it, and as far as I know, that's the cap dump, where you actually short the cap into something, and that's when we can convert. So with that said, as I showed before, I got the meter on the output here, and it does funny things. It likes to ramp up on its own here at random intervals and numbers here. But that was for earlier videos. That's not what I'm concerned about right now, but that's why you're seeing 006, because it should be 0, but you know, this thing never really goes off. So anyways, what I'm going to do is I'm going to turn it on now. So I'm going to put in the first thing here is going to be the controller. So we're going to turn the controller on. So our controller is on here, and I am doing that at high frequency, 28K at 1% here. It responds the best. So now we're going to turn on the high voltage module. I gotta get it right here. It's hard doing everything with one hand. Oh. There we are. And the input here takes more power, folks. It's regular DC, 9 volts, 100 milliamps. But you'll understand why I'm sacrificing this. Look at the power on the meter. Over 1,000 volts here, okay? Now you must be wondering, this is instant, with zero trigger basically. And you're going to ask yourself, wait a minute, that little 15 UF capacitor could only handle about 150 volts. This is going to blow up. Remember, folks, this is a completely different kind of energy. It behaves in semiconductors differently. It'll measure as DC, but it doesn't act like DC. So with that said, it does interesting things. Like it will run certain things, like certain lights and whatnot, and that's the interesting thing. And I'm going to show you that right now. So I'm going to plug in the light, and you'll see it takes a moment, but the load adjusts itself right away, and it doesn't really affect the output. It's like this light is not even connected to the output. And what's fascinating, folks, is to show you this is a different kind of energy. This light is an AC lamp. It needs 100 volts AC to light up. I tried running it off DC. It will not work. But remember, this is the rectified capacitor here. So supposedly this is DC, but it's not loading it up. It's seeing it as AC even though it's not, and it's not affecting our output at all. Because again, this is cold energy. It's a different kind of system. So let me show you the temperature here. See, this is right in the middle, 75. And let's go to the core here. See, there's no heating, really. So this is what I mean. And there is, because look at the controller here. There's nothing wrong with my thing, because if I go to the controller, because it's lit up, see? So this thing's working fine. But this all runs cold. The wires run cold. Yet we have this crazy thing going on here. And we're not blowing anything up. Now I wanted to know, you know, so basically I asked ChatGPT, this is an instant charge. I said, what happens if I dump? I was generous. This is 15 UF. I said 10 UF. Let's say 100 dumps a second into a microwave transformer with another transformer, 12 volts at the end, right? So at 12 volts, it told me I would get something around 500 watts. Crazy, but I'm not kidding. Because once we dump this, it becomes traditional energy again. And this is able to sustain its instant. So I could show you the spark. It's pretty big. I'd rather not do it, but I'm not joking. When this, I'd rather not do it. This is very high voltage. But if I turn it off, I'm going to kill the trigger here. I'll give it a chance to ramp down a little. But look at the light, it still runs, and I've turned the trigger off for a while because, see, it's like not directly coupled to the voltage, remember? There's no more input here, and the capacitance isn't that much. This is not what you'd expect from a normal capacitor. This would have been, especially under a load, you see? So anyways, I can, well, there wasn't enough in there, but the point is you get that big green spark like Bedini was getting. And, you know, it goes out a few inches. So, again, I'd rather not do that. But look what happens, you know, the voltage is coming back up. So, yeah, so that's the thing here. So we're getting 1 kilovolt output at 15 UF. And it's instant, and we can dump that. I don't know about a transistor, so I'm thinking a tube circuit with a 555 timer I could precisely control. I don't mind, you know, even if we have to take a couple watts to heat up the tube, if we're going to get 500 watts output on the 12 volt side, ChatGPT told me I would need something like 2,600 UF smoothing capacitor. That's crazy. So my logic is, you know what, dump it directly into a 12 volt battery like over here and run your load directly, your 500 watt. And if you know what this means, folks, 500 watts, that's your little infrared heaters. So here's your heat in the winter time. This potentially solves the problem of heat as well. Because 500 watts is getting serious. Okay, we need to put maybe 100 milliamps into the input. It's not quite, you know, zero input trigger, but sacrificing 100 milliwatts for 500 watts, 12 volts output, good enough.